This video is going to discuss a few of the basic concepts dealing with energy. And in this video, we're just going to talk about the different types of energy and how they are affected by the objects that the energy interacts with. So there are some notes that are out on Canvas that were handed out. Oh, here we go. It's going to focus in on that. It's called Energy Notes, Energy Transfer, or Energy Storage and Transfer Model. I'm not going to read through this whole thing, but the main parts of this are bold and underlined. They're highlighted. Energy is really, excuse me, involved when there's a change, when there's an interaction between some objects and something about those objects change. There's some sort of energy that is flowing through the system of objects, and we'll talk about the system here momentarily, that is causing that change. The energy itself is unchanged, though, and that's what's underlined here. The energy, as it flows through the interactions, can, I guess, you've probably learned it as different forms, and forms may not be the worst word. We kind of look at it maybe as different accounts, different places where this energy is stored as it is moving through these interactions. So I have a few different ones here, and I'm just going to kind of highlight them quickly here, and then we're going to make a list and talk a little bit more about them in just a minute. All right, so, excuse me. So to start with, we call it kinetic energy when an object is moving, or kinetically stored energy when an object is moving. And our little symbol for that, we have a triangle because the amount of this energy tends to change as it flows through these different forms or these different accounts, right? So the triangle stands for change in, E is energy, and K is for kinetic, and these all follow the same format. In fact, let me maybe just zoom in just a touch. So, wrong way. So that these are a little bit easier to possibly see. There we go. We call it elastic or elastically stored energy when an object undergoes a restorable deformation. That means this thing is stretched or compressed or bent. That would be like springs or rubber bands when they are stretched, or springs when they are compressed. Gravitationally stored is when an object moves vertically in a gravitational field. In other words, it moves up or down, right? Because the gravitational field of the Earth pulls down. Everything tends to be pulled down. So we'll get back to that one in just a moment and maybe explain what that looks like in more detail. Electrically stored is when a charged object moves through an electric field, meaning anything dealing with electricity, which I'm sorry I didn't highlight these. Elastic is E with an EL. Gravitationally stored energy is E with the G. Electrically stored is E with a Q. Q is our symbol for charge, which we'll be looking at in the next unit, so that EQ might make more sense then. Chemically stored, where chemical reactions release energy. This is mainly found in either batteries or living things, right? Their cells, the mitochondria, take the sugars, whatever, and do energy, right? And that's what our cells use then for energy. Thermal energy is what we're going to call for the energy when it just goes into the atoms and makes the atoms move more quickly and makes them move more random. And when that happens, when the energy flows into this type of energy, we cannot get it back out again. And we'll talk more about that in a video later. So this is ETH. So we're actually going to take these kind of one at a time and talk about them in a little more detail. Right? So we're starting with EK, kinetic energy. So, sorry, I was really having some focusing issues this evening. So move my hand in and out. It may kind of focus in and out, but I'll try not to move too much here. That means an object is moving, right? So in terms of what is going on with this, if it's moving faster, right, that means the kinetic energy will be increasing. We'll be getting more, right? And that does mean that if something is moving more slowly, right, so if something is slowing down, it means this kinetic energy will be decreasing. Right? If something has a constant speed, the amount of this kinetically stored energy or kinetic energy is going to remain constant. So that is kinetic energy. Anything that is moving at all has kinetically stored energy. If it's not moving at all, it does not have any kinetically stored energy. Once again, the faster it's moving, the more of this kinetically stored energy it has. The more slowly it's moving, the less kinetic energy or kinetically stored energy it has. Elastically stored, right? That is when something is bent or stretched. So once again, the more it is, we can say the word deformed, even though, I don't know, stretched, bent, compressed might be better. right, that means this elastic energy is going to be higher. So once again, the more you stretch a rubber band, right, the more energy it has. Or for a spring that is made to compress, the further you compress it, the more of this elastically stored energy it has. There are formulas for both of these, and for the gravitationally stored also, that we'll get to here in just a moment. We will probably be going over those in class eventually. So we'll find out exactly how much more energy we have when something is stretched further. Right? And so if it becomes less, and this time maybe I'll just use the stretched form, right? Less stretched, less compressed, less bent, this elastically stored energy goes down. Right? So, and once again, we may be talking with the exact formulas about how that occurs in class. Okay, just a few more of these, right? For gravitationally stored energy, this depends upon the vertical distance something can fall, right? And it doesn't necessarily need to be falling. It could be on a ramp or something. But just in general, right? I'm just going to make these as easy as possible, right? The higher the object is, we'll just say it that way, the larger the gravitational energy is. So if something is moving up a hill or moving up a ramp, or you're just lifting it straight up, right, it's the vertical distance that matters. It doesn't really matter kind of sideways how far something might go up a ramp or go up a hill. The higher it is, the higher the gravitationally stored energy is. And then that means the lower the object is, the gravitationally stored energy becomes less. So there is a thing with this gravitationally stored energy too. You need to decide, and you get to decide, where you are calling zero for the gravitationally stored energy. So as we go through some examples here, we will talk about that. We will talk about how that might change our model of where the energy resides depending upon where we choose that point. So for right now, you just need to know that I will be expecting you in your models to be labeling where you want this gravitationally stored energy to become zero. Now for the rest of them, it's a little bit harder to actually talk about what makes more or less. For electrically stored, it depends upon several things called current and voltage, and those things we'll be getting into next unit. So we're not going to be talking about electrically stored quite so much in terms of how to make it bigger or smaller. Chemically stored, basically for something like gasoline, right? The longer vehicle runs, the less chemical energy that is in there. On the other hand, if you go to your gas station and refill your tank, then the chemical energy becomes greater. Same thing with a battery, right? The longer it is plugged into a device that is running, the less less chemically stored energy there is, because that chemically stored energy has been transferred or transformed or converted. I don't know what words you would like to use. They're all fine. Into the place where there is light energy or sound energy, depending upon what the device is. Thermal energy, same sort of thing. Thermal energy is what most people would probably think of as heat, right? And that is usually created as energy flows through other systems, especially chemical energy tends to, as it flows into other accounts, some of that always tends to go into thermal, and also elastic energy. As a spring is bent and compressed a lot, and the elastic energy might convert into kinetic energy if it makes something move, a fair amount of that is turned into thermal energy also. So for the electrical energy, the EQ, that really just depends upon some things we will be talking about. Chemical energy, it really depends upon the object with the energy. You know, a human body, the longer you live, the more chemical energy you expend until you eat again, right? And then that food gives you more chemical energy. Batteries, it depends upon how long they've been running. And then thermal energy, right? That is one that it depends upon just what is creating this thermal energy from something else, where this thermal energy is coming from, and how that will be greater or smaller. So these are overall our 6 types of energy that we're looking at. Well, I guess I did forget one, right? There is also, sorry, I forgot this on the notes the first time. There is one we are going to call ER, which is radiationally stored energy. So if I were going to take that one, just talk about it just real briefly, that is a form of energy that is found in light. So light is a form of radiation. Our last unit of the year is going to be talking about light and sound and other types of wave energies. So we're just going to use ER for radiation to stand for the amount of energy that is carried by light. So we have 7. We have the kinetically stored energy, elastically stored energy, gravitationally stored energy, and then electrically stored energy, chemically stored energy, thermal energy, and radiationally stored energy. So those will be the type of energies we'll be looking at, and we'll be looking at just different interactions where this energy is flowing between all of these different forms throughout the interaction. That will be the next video, and we're going to talk about the pie charts and how we model the interactions and the energy flows. Thanks for watching.